Hello everyone, Assalamualaikum warahmatullahi wabarakatuh and good day to every one of you. Welcome to my video. So basically this is a continuation video for a lecture on chapter 2 which is Transformer. So here is my name and this is my email address norzulaili@uitm.edu.my. So you can just feel free to email me whenever you have a question regarding the content of this video. Okay. Alright, so let's move to the next slide where we are going to see what are the contents, what are the subtopics that we are going to cover in this video. So basically in this video we are going to cover on the subtopic of equivalent circuit parameter for a practical transformer, where we are going to learn on how to determine each of the parameter for the circuit. Okay, so now let's move to the subtopics of equivalent circuit parameters. Okay, so basically in this video we are going to learn on how to determine the equivalent circuit parameters of a practical transformer. Okay, so if you have a look at this diagram, here is the representation of the equivalent circuit parameters for a practical transformer. Okay, where you have a all the impedance are referred to the primary. Okay, alright. So in order to predict the behavior of the transformer, okay, so in order to predict the behavior of this circuit, the circuit parameters must be known. Okay, so the circuit parameters include the value of R1, X1, X2 prime, R2 prime, RC1, and also XM1. Okay, so we need to determine each of the value of the circuit parameters. Okay, so the value actually can be calculated from the dimension and also properties of the material that used in the transformer. However, some are difficult to be obtained. So therefore, we are going to use a simple direct method by performing tests that involve the power consumption known as open circuit test and also the short circuit test. Okay, so basically there are two different tests that we are going to perform in order to determine each of the circuit parameter value. Okay, so basically in order to determine the value of RC1 and also XM1, okay, both of this value can be determined based on the open circuit test. Okay, and then for the value of R equivalent and also X equivalent, which is include R1, R2 prime, X1 and X2 prime. Okay, all this value can be determined based on the short circuit test. Okay, so both of these tests we will see in details in the next following slides. Okay, so first we go to the first test, which is open circuit test. So basically the open circuit test is used to determine the value of RC1 and also XM1. Okay, so this is the wiring diagram for the open circuit test, where we connect the ammeter and wattmeter, and also we connect the voltmeter to the primary side of the transformer. Okay, so based on this, the equivalent circuit under the open circuit test is just like this. Okay, you can see that you have a primer voltage. Okay, this is the primer current. Okay, so it connects to the RC1 and also XM1 in parallel. Okay, alright. So this is the topology for the open circuit test. Okay, so basically in order to determine the value of the RC1 and also the XM1 for the open circuit test, there are two different steps that you need to follow. Step number 1, you need to check, okay, if the value of the voltage open circuit is equal to the V1, okay, if the output of the open circuit test of voltage open circuit equal to V1, therefore the value of RC1 and XM1 that you determine is referred to the primary side. However, if the voltage of the open circuit test equal to V2, okay, if the voltage open circuit test is equal to V2, therefore, the value of the RC1 and also XM1 is referred to the secondary side. Okay, we will see in details in the next following example on how to determine these two. Okay, so step number 1, you need to determine the value of VOC, whether it is equal to V1 or the VOC equal to V2. Then next, the step number 2, we need to calculate the value of the theta. Okay, so the theta open circuit will be equal to cos -1 power of open circuit divided by voltage of open circuit multiplied with current of open circuit. So basically this is based on the formula of P equal to IV cos theta. Alright, and then the value of the XM1 and also the value of RC1 you can determine based on this formula, where you have for the XM1 is actually equal to the V open circuit, okay, because the V open circuit is measured from this terminal to this terminal, okay, so that's why from this terminal to this terminal, okay, both sides, alright, so the V open circuit divided by the IM, because IM is the one go through the XM1. For the RC1 is equal to the voltage across here, V open circuit divided by IC. Okay, alright, that's how you determine the value of XM1 and also RC1. Alright, so how about the value of IM and also IC? If you don't have the value of IM and IC, you can just use the concept of triangle. Okay, based on the trigonometry, you know that the IC and also IM is separate by 90 degree here. Okay, so here you have IC, here you have IM, and then I phase is represent by the angle of theta C here. Okay, so by applying the trigonometry rules, you know that in order to get the IM will be equal to the I open circuit. Okay, here is your I open circuit multiplied with sin theta. Or IC will be equal to I open circuit. Here is your I open circuit multiplied with cos theta. Okay, so basically the I phase is equal to your I open circuit. Alright. Okay, so basically you need to memorize all this formula, okay, in order to get the value of RC1 and also XM1. Okay, so that is for the open circuit test. The open circuit test is used to determine the value of RC1 and XM1. Okay, next we go to the second test, which is short circuit test. Okay, so for the short circuit test, we used to in order to determine the R equivalent and also X equivalent. This will be include your R1, R2, XL1 and also XL2. Okay, so basically this is the wiring diagram for the short circuit test. Okay, same as per previous slide. You also connect the ammeter, wattmeter and also voltmeter to the either to the primary side or to the secondary side. Okay, and then this is the equivalent circuit for a short circuit test. Okay, so where you have a combination of the voltage and you have a current there, and then it has a R equivalent and also X equivalent. Alright, so basically this is the topology for a short circuit test condition. Okay, so there are also two different steps that you need to follow in order to determine the value of R equivalent and X equivalent from the short circuit test. Okay, for step number 1, you need to check whether the I short circuit current is equal to I1 or equal to I2. Okay, so basically the value here is the I short circuit from the ammeter reading. Okay, so the I short circuit is equal to I1 or I2. If the I short circuit equal to I1, therefore the R equivalent and also X equivalent is referred to the primary side. Okay, however, if the I short circuit current is equal to the I2, meaning that the R equivalent and also X equivalent is referred to the secondary side. Okay, alright. And then if the value of I1 and I2 is not given in the question, then you can determine the value of I1 and I2 based on this formula, where your I1 is equal to S rated divided by V1 and I2 is equal to S rated divided by V2. Okay, so V1 is actually the voltage at the primary winding and the V2 is a voltage at the secondary winding. Okay, alright. And then step number 2, you need to determine the theta for the short circuit. Okay, by using the formula of P equal to IV cos theta. So you can find the value of theta for the short circuit. Okay, so the power of the short circuit is coming from the reading from your wattmeter. Okay, it's given in the question. And then the voltage for short circuit is equal to here. This is the reading from your voltmeter. And then the I short circuit is given by this, which is the reading from your ammeter. Alright, and then you can also the Z equivalent. So where the Z equivalent will be equal to the voltage short circuit divided by current short circuit. Okay, this is based on the Ohm's law, where Z will be equal to V divided by I. Alright, and then the voltage of the short circuit, usually the theta is equal to 0, and then the I short circuit will be depends on the value of the negative theta short circuit. Okay, so based on this value, you put here. Alright, and then based on the Z equivalent, then only we can find the R equivalent and also X equivalent, where your Z equivalent will be equal to R equivalent plus J X equivalent. Alright, so that is how you determine the value of Rx equivalent and also X equivalent based on the short circuit test. Okay, so we will see in details on how to apply both tests, include open circuit test and also short circuit test, in the next following example. Okay, now we go to the example 2.2. So the question here, tests are performed on a 10 kVA, 2200/220 volt, 60 Hz single phase transformer, and the following results are obtained. Okay, so basically you are having two different tests here. You are having open circuit test with the value of voltmeter reading, ammeter reading, and also wattmeter reading. Okay, and then this is the data for the short circuit test. Okay, here is the voltmeter reading, ammeter reading, and also wattmeter reading. Alright, okay, so basically the S rated is given by 10 kVA. This is the V1, which is the voltage at the primer winding, 2200 volt, and this is the V2, 220 volt. Okay, alright, so question number A, basically we will answer focus only on question number A. So question number A, determine the parameter for the approximate equivalent circuits. Refer to the low voltage side and also the high voltage side. So meaning that we need to determine each of the parameter for the transformer equivalent circuit. Include, we need to determine the RC1, XM1, R1, R2, XL1, and also XL2. Okay, and then we need to repeat the step for both question. Okay, first one we need to refer to the low voltage side, and then the second one we need to refer to the high voltage side. Okay, so first of all, based on the open circuit test, we need to find the value of RC1 and also XM1. Okay, so basically this is the open circuit test data that we get from the question, where the voltmeter reading is 220 volt, and ammeter reading is 2.5 ampere, and wattmeter reading is 100 watt. Okay, so first step number 1, you need to determine whether the value of RC1 and XM1 is referred to the primary side or secondary side. So how to determine that? You need to check for the value of the V open circuit, whether it is equal to V1 or V2. Okay, so in this case, your V open circuit is equal to 220 volt. So the 220 volt is actually equal to V2. So you know that now your RC1 and also XM1 are referred to the secondary side. Okay, and then step number 2, you need to find the value of RC1 and also XM1 based on the formula. Okay, so formula number 1, based on the P equal to IV cos theta, you can find the value of the theta open circuit. Okay, so the theta open circuit will be equal to cos -1 divided by the power of open circuit divided by current of open circuit multiplied with voltage of open circuit. Okay, so basically the power of open circuit is given by here, 100 watt divided by current of open circuit 2.5 multiplied with 220 volt. Voltage of open circuit, and then you find the value of cos -1. So you can get the theta of open circuit is equal to 79.52. Okay, here is your theta of open circuit. So basically the theta of open circuit is the theta for the I open circuit. Okay, alright, so based on the triangle, you can apply the trigonometry rules to find the value of IC and also IM. Okay, so you know your IC is equal to I open circuit multiplied with cos theta C. So you just key in the value of I open circuit, in this case is 2.5 ampere, multiplied with cos 79.52. Okay, and then you get the value of IC is equal to 0.45 ampere. And then for the IM, if you refer to the triangle here, you apply the trigonometry, IM will be equal to I open circuit multiply with sine theta C. Okay, so you just key in the value I open circuit is 2.5 ampere multiply with sine 79.52 degree equal to 2.46 ampere. Okay, so now you have get the value of IM and also IC, then only you can find the value of RC1 and also XM1. Okay, so RC1 will be equal to the VOC divided by IC. Okay, so VOC is given by 220 divided by IC is 0.45. So you get 488.89 ohm. For the XM1 is equal to the voltage open circuit divided by IM. Okay, so in this case 220 divided by 2.46 ampere. So you get 89.43 ohm. Okay, so remember, based on the step number 1, you know that your RC1 and also XM1 are referred to the secondary side. So that's why here I put RC1 prime and XM1 prime because both of this value is referred to the secondary side. So we put prime here. Okay? And then next we go to the second test, which is the short circuit test. Okay, so for the short circuit test, we use the data in order to find the R equivalent and also X equivalent. Okay, step number 1, you need to check whether your R equivalent and X equivalent is referred to the primary side or the secondary side. So you need to check the value of your I short circuit. Okay, you need to check the value of I short circuit, whether it is equal to I1 or I2. So first of all, because the question doesn't give the value of I1 and also I2, we need to calculate based on the formula. The question gives you the value of V1 and also V2, and then you can find the value of I1 and also I2. Okay, I1 will be equal to S rated divided by V1. So in this case, S rated is 10 kVA divided by V1. V1 is 2200. So you get 4.54 ampere. So I1 is given by 4.54 ampere. For I2, same formula. You just I2 is equal to S rated divided by V2. So you get 45.45 ampere. And then, based on the value of I1 and I2, you check whether the value of I short circuit equal to I1 or I2. Okay, in this case, your I short circuit is 4.55. Okay, so it is considered equivalent to your I1. Here you have 4.54. Okay, so it is equal to I1. So we can conclude that your R equivalent and also X equivalent are referred to the primary side. Okay, because the I short circuit now is equal to I1. So it is referred to the primary side. Okay. And then next, step number 2, you can determine the value of your R equivalent and also the X equivalent based on the formula given. So based on the formula of P equal to I V cos theta, you can find your theta short circuit. Okay, so the theta short circuit will be equal to the cos negative 1 equal to power of short circuit divided by current of short circuit multiplied with voltage of short circuit. Okay, so basically the theta of short circuit represent the theta for the I short circuit. Okay, remember it represent the theta for the I short circuit here. Alright, so in order to find for the theta short circuit, you just key in the value. Power of the short circuit is given by 215 watt. Okay, and then I short circuit given by 4.55. Voltage short circuit is given by 150. So you just key in the value, you get theta short circuit is equal to 71.63 degree. And then based on this value, you can find the value of the Z equivalent. So Z equivalent, by applying the Ohm's law, you know Z will be equal to V divided by I. So in this case, V short circuit is equal to 150. The angle is 0. And then for the I short circuit is 4.55. And then the angle of the short circuit is given by this answer. Okay, so it is negative short circuit. So negative 71.63 degree. Okay, and then you just key in the value into your calculator. You get the Z equivalent will be equal to 10.4 plus J 31.29. Okay, so this is basically represent your R equivalent. And then this is your X equivalent. Alright. So now you had find the value of RC1, XM1, R equivalent and also X equivalent based on the open circuit test and also short circuit test. And then in the next slide, we will try to determine the parameter for the approximate equivalent circuit. That refer to the, first you need to find for the low voltage side, and then the second question you need to refer to the high voltage side. Okay, first we go to the low voltage side. Okay, from the question, you know that the transformer parameter is given by, the ratio is given by the 2200/220 volt. Okay, so in this case, low voltage is referred to the secondary side. Okay, so that's why your equivalent circuit must be in terms of the equivalent circuit refer to the secondary side. Okay, so you need to come up with the circuit that refer to the secondary side like this. Alright, okay. So from the open circuit test, you know, the RC1 prime that you get is equal to 488.89 ohm, and then the JXM1 prime is equal to J89.43 ohm. Okay, and then from the short circuit test, you also get the Z equivalent. Z equivalent that refer to the primary. So here is the RC and also XM refer to the secondary. Okay, and then the value of the Z equivalent is equal to 10.4 plus J31.29 ohm. Okay, from the question, you know that you need to determine the parameter for the equivalent circuit that refer to the secondary side, because it is referred to the low voltage side. So your equivalent circuit must be referred to the secondary side. So that's why you must convert all this value to the secondary side. Okay, for the RC1 and XM1 is already referred to the secondary side, but here you have the value referred to the primary. So you need to convert first this value to the secondary side. Okay, so we need to convert the Z equivalent 1 to the secondary side. So by using the formula of Z equivalent 2, meaning that you refer to the secondary side, is equal to Z equivalent 1 divided by A squared. So how to find the value of A? A is equal to V1 divided by V2. So in this case, V1 is 2200 divided by V2 is 220. So you get 10. Okay, once you find the value of A, then you can just key in into this formula. So finally, you get the Z equivalent that referred to the secondary side is given by 0.104 plus J 0.313 ohm. Okay, so this is the Z equivalent referred to the primary secondary side. So this is the RC referred to the secondary side, and this is the XM referred to the secondary side. So once you get all this value, then only you can draw the equivalent circuit. Okay, so this is the equivalent circuit that refer to the secondary side, where the value of the V1 that refer to the secondary side is equal to V1 divided by A. So in this case, is V1 prime is equal to 220 volt. Okay, so this is for V1 prime. For the I1 prime, the formula is given by AI1. So A is 10, you just key in the value, you get 45.4 ampere. Okay, for the V2 is already at the secondary side, so V2 is equal to 20 volt. And then I2 also is equal to 45.45. Okay, so basically this value is coming from the calculation that you get in the previous slide. Okay, once you get all the value of V1 prime, R1 prime, V2 and I2, then you can write down the value of the RC, XM, R equivalent and also X equivalent. Okay, so in this case, RC1 prime is equal to 488.89 ohm. Okay, this is based on the value from the previous slide. So this slide, okay, so here, and also here. Okay, so your JXM1 prime is equal to J89.43 ohm. And then your R equivalent that refer to the secondary side is equal to 0.104 ohm. And then your X equivalent that refer to the secondary side is equal to J 0.313 ohm. Okay, so that is how you determine each of the parameter for the equivalent circuit that refer to the secondary side. Alright, okay. So next we go to the number 2, which is we need to find the equivalence, we need to determine the parameter for the equivalent circuit that refer to the high voltage side. Okay, so same thing as in the previous slide, which we check whether the high voltage side is referred to the secondary or primary. So from the question, you know the ratio of the transformer ratio is given by 2200/220 volt. So high voltage is basically represented by this. Okay, so it is considered refer to the primary side. Okay, so the HV side is at primary side. Okay, so from the open circuit test, you got RC1 prime and XM1 prime is referred to the secondary side. So you need to convert this thing to the primary side first. Okay, for the short circuit test, you got Z equivalent 1 is already referred to the primary side. So that's why for here, you don't need to change anything. You just need to change the value of this, and this you need to convert in order to refer to the primary side. Okay, we need to convert RC1 prime and XM1 prime to RC1 and XM1. We need to convert to the primary side. Okay, so in this case, we need to find the value of A. Again, A is equal to 10. Okay, just key in into the formula. You know RC1 will be equal to A squared RC1 prime. So just key in the value. You get RC1 is equal to 48.89 kilo ohm. Okay, and then for the XM1 is equal to 8.94 kilo ohm. Okay, so this is basically based on the impedance transfer formula. Okay, once you already convert all the value of RC1, XM1, Z equivalent, all the value already transferred to the primary side, then only you can draw the equivalent circuit. Okay, so this is the approximate equivalent circuit that refer to the primary side or refer to the high voltage side. Okay, and then you can label each of the parameter accordingly. So in this case, here is your voltage, primer voltage. Okay, so V1 is equal to 2200 volt. Okay, so V1 is already referred to the primary side, so that's why you don't need to change anything. So V1 is equal to this, and then for I1 is equal to 4.55 ampere. So this is the based on the calculation S rated divided by V1. Okay, and then for the V2 prime, because now you refer all the parameter from secondary to the primary, so that's why you have V2 prime. So V2 prime is equal to AV2. This is based on the formula of impedance transfer. You need to memorize. Okay, so V2 prime is equal to AV2. You just key in the value of A is 10, multiply with 220 volt. So finally you get 2200 volt. Okay, and then for the I2 prime is equal to I2 divided by A, so you get 4.55 ampere. Next, the value of RC1 referred to the primary side is given by 48.89 kilo ohm, and then the JXM1 is equal to J8.94 kilo ohm. Okay, and then for the R equivalent 1 is equal to 10.5 ohm. And finally, the JX equivalent 1 equal to J31.29 ohm. Okay, so basically this is the approximate equivalent circuit referred to the high voltage side or primary side. Right? Okay, so that's all for now. Thank you for watching my video. Thank you for your time. I'll see you in my next video. Okay, bye.